For problem 1, an object is at rest at the origin at t equals 0 seconds, then it moves forward with a constant acceleration, a equals 1 meters per second squared, from t equals 0 to t equals 1, then with an acceleration of 2 meters per second from t equals 1 to t equals 2, then with an acceleration of 3 meters per second from t equals 2 to t equals 3, and so on for eternity. First, I had to draw an acceleration versus time graph of the motion of this object during the first 10 seconds. So I put acceleration on the y-axis and time on the x-axis in increments of 1. And with the given information, I knew that my first line needed to be from 0, 1 to 1, 1, because at the 0th second, the acceleration was 0, but once it started moving, it was 1 meter per second, and then from there, right after 1 second, it jumped up to 2 meters per second, all the way until 2 seconds, and then right after 2 seconds had completed, it jumped up to 3 meters per second for 1 second, and so on for the 10 seconds. And then I needed to find the object's velocity at the end of the 5th second, and for that I used this equation, and I found that at the end of the 5th second we have a velocity of 15 meters per second. I came to that conclusion because the initial velocity was 0, the acceleration was 1, and then the change of time was 1 second, so 1. And then I plugged that into the next one, 1 second plus an acceleration of 2 meters per second times a change in time of 1 second is equal to 3, and then so on, and I got to 15. And then the name for this formula is an arithmetic sequence, because up here we have this. This can also just be described as v of 1 is equal to 1, v of 2 is equal to 1 plus 2, v of 3 is equal to 1 plus 2 plus 3, and so on for eternity. For infinite, that is still terrible. No. Okay, we're just going to draw 2 circles and call that good for infinity. So yeah, that is all for question 1.